This video is going to talk to you about the characteristics of functions that are graphed on the same coordinate graph. So the first thing that you need to know is when you're looking at these kinds of problems, it's really important to understand what the questions are asking you. So for this first question, it says, for what domain values are both of the functions equivalent? Well, when we say domain values, what we're really just talking about are the x values. So what we want to look at are where on these two functions are our x values equivalent. And the places where they're going to be equivalent are where our two lines intersect. So we have one intersection right here, which if I follow this line down, is at -6. So I can say that these two lines are equivalent where x equals -6. And I can also see another intersection right here, which is where x equals 2. Okay, those two numbers are going to be really, really important for us. So what I'm going to do in just a second, let me clear these two lines off. I want to make them really obvious for us. These two lines at -6, these two x values at -6 and at 2 are going to help us divide this graph into 3 sections. Okay, and those 3 sections are going to be really, really important for us when we go to analyze some more parts of this function. So not only am I going to put those dividing lines here, I'm going to label them. This yellow line right here is where x equals -6, and this yellow line here is where x equals 2. Now before we start analyzing anything else, let's talk a little bit about how we've broken up this graph. Okay, everything that's in between these two sections, we're going to say is in between -6 and +2. So it's all the x values that occur in between these two things. Now over here on this side, this is where everything is less than -6. Okay, and if you're not sure about that, this is -6 here, -7, -8, all the numbers here on the left are less than -6. Same way we look at that, over here, everything on the right side here is going to be greater than 2. And again, check it out, this is 2, 3, and 4, and everything to the right will then be greater than 2. Okay, so now we've really kind of broken down our graph into sections, and it's really important for us to understand that those sections are going to help us with these next few questions. So this next question says, on what interval is b of x greater than r of x? Well, the word interval really is just referring to what section of our graph is b of x greater than r of x. If you look, b of x, that's our blue line, and r of x is our red line. So what this question is asking us is in what section of this graph is our blue line greater than our red line? So what we want to do is we want to look at this graph in sections. So I'm going to start looking at just this left section over here. And when I look at this, I can see my blue line here, and I can see my red line here. Now, the way we can tell a line is greater, it's going to have greater y values. It's going to be above the other line. So in this question, we want to know where our blue line is above our red line. That's not this section, because we can see our red line is above our blue line. So now we'll look at our middle section. And when we look at our middle section, we can see right here, our blue line is above our red line. Okay, so our blue line in this section is going to be greater than my red line. So now that we know which section we're talking about, we just have to name it. And so what I'm going to do is I'm going to take these blockers that I have, and I'm going to cover up these other intervals that I'm talking about. And I'm talking about everything that's just in the middle here, which means this is the interval right here where blue is greater than red. And what I would do is I would write that blue is greater than red in between -6 and +2. And I'm going to write it in interval notation like that. Now my last question says, in what intervals will r of x exceed the values of b of x? So again, let's break this down. What intervals mean what sections? Okay, so in what sections will the red line, r of x, exceed? Exceed means be bigger. Okay, so exceed means be bigger or greater than our blue line, b of x. So where is the red line greater than the blue line? Well, we know it's not this middle section, right? Because right here we already decided that blue was greater So let's look at our other sections that we have. Okay, I'm going to cover this section up. Let's go back over here. If I look over here, I can see that my red line here is above my blue line, which means my red line is greater, which means that this interval is where red is greater than blue. So I'm going to write that down. Red is greater than blue when x is less than -6. Now we know it's not the middle section, but let's double check this right-hand section too. Look at your blue line, which is here. Look at your red line, which is here. We can see our red line is greater, which means this section also is an answer to our question, that our red line is greater than our blue line when x is greater than 2. Okay, so understanding your questions is really important to being able to read these graphs. Now, there's one other thing you might be asked to do, and that includes our function notation. Again, understanding these questions is the key to this, so think back to function notation. Whatever you had in your parentheses, that's your x value. Whatever's after your equal sign is your y value. So what this question says is, okay, look at your red line. When the x value is 2 on your red line, what's the y value? So what you do is you go to where your x value is 2, go up to your red line, and then figure out what y value matches that. In this case, that y value would be 1. Now remember, these two numbers fit together to make an ordered pair, 2, 1, and that ordered pair is this point we're talking about right here, where x is 2 and y is 1. Let's do the next one. So in this case, remember, this is x, this is y. This is saying, okay, when your x value is -3 for your blue line, what's the y value? So go to your x value of -3, go up to your blue line, and go over and see what your y value would be. In this case, would be 6. So again, we're talking about the ordered pair, -3, 6. Now we're going to flip things around just a little bit here. Okay, this question gives you your y value, but it doesn't have your x value. So it's the same kind of thing, except this is saying, okay, on your red line, when your y value is 9, what's x going to be? So this time we're going up to our y value of 9, and we're going to go over till we meet our red line. And then we got to figure out what that x value would be, and it would be that x equals -6. And if I wrote it as an ordered pair, it would look like that. And then finally, last but not least, we're going to be looking at our blue line here. Okay, and so again, this is my x value, this is my y value. So for my blue line, we're looking for where our y value is 2. So y value of 2, I go over to my blue line, and I find that x equals 1. And that would be an ordered pair of 1, 2. So these are the kinds of things you're going to be expected to do when you analyze 2 or more functions on the same coordinate graph.